Did you know that there are tests being conducted utilizing app on mental patients and entire small towns in Arizona? In 2023 it's called Cybernetics Research by DF Light and Nova. There can be various purposes or objectives for conducting a cybernetic program in a small town. Here are a few possible reasons. 1. Testing and validation. Conducting a cybernetic program in a small town can serve as a controlled environment to test and validate the effectiveness, feasibility, and impact of cybernetic systems or technologies. The smaller scale allows for easier monitoring and evaluation of the system's performance and outcomes. 2. Research and innovation. A small town can provide a unique setting for researchers to explore the sociological, economic, and environmental impacts of cybernetics. It can generate valuable data and insights on human-machine interactions, social dynamics, and the benefits or challenges associated with implementing cybernetic systems in real-world contexts. 3. Community engagement and empowerment. Involving a small town in a cybernetic program can foster community engagement, collaboration, and empowerment. It allows residents to actively participate in decision-making processes, co-design solutions, and shape the development and implementation of technology in their community. 4. Sustainable development. Cybernetic programs in small towns can focus on sustainable development objectives. This might involve optimizing energy usage, improving transportation systems, enhancing resource management, or creating smart infrastructure solutions that benefit both the environment and the local community. 5. Economic growth and innovation ecosystems. Implementing cybernetic programs can attract investment, promote entrepreneurship, and stimulate economic growth within a small town. It can create opportunities for startups, technology companies, or research institutions to collaborate, innovate, and develop new products or services based on the cybernetic infrastructure. Ultimately, the purpose of conducting a cybernetic program in a small town can vary depending on the specific goals, priorities, and needs of the community and the researchers involved. Putting a town under the influence of cybernetics is a complex and multifaceted process that would require careful planning, implementation, and integration of various components. The time it would take to execute such a program can vary significantly depending on factors such as the scale of the town, the specific objectives of the cybernetic influence, available resources, and the complexity of the technology being deployed. Generally speaking, the implementation of a comprehensive cybernetic system in a town would likely require an extended period of time. This could involve several phases, including research and development, infrastructure setup, system testing, community engagement, and gradual deployment. The timeline could span anywhere from a few months to several years. It is crucial to note that any implementation of cybernetics should be conducted with careful consideration of ethical implications, privacy concerns, and community consent. Engaging with stakeholders, conducting feasibility studies, and obtaining necessary approvals and permits would likely add to the overall timeline. It is important to emphasize that the hypothetical scenario of putting an entire town under the influence of cybernetics raises significant ethical concerns and would require extensive planning, collaboration, and oversight to ensure responsible and respectful implementation. The end result of a sociological experiment involving cybernetics would depend on the specific objectives and design of the study. However, some potential outcomes or insights that could arise from such an experiment include: 1. Understanding human-machine interaction. By studying the interactions between humans and cybernetic systems, the experiment could provide insights into how people adapt, perceive, and collaborate with technology. This understanding of human-machine interaction can inform the design of future technologies and improve user experiences. 2. Identifying social and behavioral patterns. The experiment may uncover new social patterns, behavior changes, or emerging norms within the community as a result of the cybernetic influence. This can shed light on how technology impacts social dynamics, group behavior, and collective decision-making processes. 3. Assessing impact on community well-being. The experiment may evaluate the impact of cybernetics on the well-being and quality of life of individuals within the community. This could involve measuring factors like satisfaction, happiness, connectivity, or access to services to understand how the technology affects various aspects of community life. 4. Evaluating ethical and societal implications. The experiment would likely prompt discussions and evaluations of the ethical considerations and societal implications of implementing cybernetics in a community setting. The findings can contribute to the development of guidelines, policies, or regulations to ensure responsible and ethical implementation of similar technologies in the future. 5. Informing policy and decision-making. The results of the sociological experiment can be used to inform policy decisions regarding the integration of cybernetics in society. Policymakers can draw upon the findings to make informed choices regarding the deployment of technology, ethical guidelines, and potential benefits and risks associated with cybernetic systems. Ultimately, the end result of a sociological experiment involving cybernetics would provide valuable insights into the social, psychological, and societal impacts of these technologies. It can shape future research, guide the development of ethical frameworks, and inform the responsible and beneficial integration of cybernetics in society. Yes, it is possible to conduct cybernetic research without the use of biotechnology or biohacking. Cybernetics is a multidisciplinary field that encompasses the study of control systems, communication between humans and machines, and the interaction of information and feedback loops. Here are a few areas of cybernetic research that do not involve biotechnology or biohacking. 1. Human-machine interfaces. The development and improvement of interfaces between humans and machines are a significant focus in cybernetic research. This may involve studying and enhancing technologies such as virtual reality, augmented reality, brain-computer interfaces, haptic feedback systems, or gesture recognition. 2. Robotics and automation. Research in robotics and automation focuses on the design, control, and application of robotic systems. This includes areas like industrial automation, autonomous vehicles, intelligent robotics, and the integration of robotics in various domains to improve efficiency, safety, and productivity. 3. Artificial intelligence and machine learning. Research in artificial intelligence, AI, and machine learning, ML, explores the development and application of algorithms and models that allow machines to learn, reason, and make decisions. This can involve studying neural networks, deep learning, natural language processing, computer vision, and other AI/ML techniques. 4. Sensors and Internet of Things, IoT. Investigating the use of sensors, data collection, and the Internet of Things, IoT, can be central to cybernetic research. This includes deploying and analyzing sensor networks, exploring data aggregation and analysis techniques, and developing systems that use IoT devices to enable efficient monitoring, control, and communication. 5. Cybernetic systems and control theory. Research in cybernetic systems and control theory involves understanding the principles of information flow, feedback loops, and system dynamics. This field explores the design and analysis of complex systems, control algorithms, stability, optimization, and adaptive control mechanisms. These are just a few examples of cybernetic research areas that do not involve biotechnology or biohacking. Cybernetics is a wide-ranging field, and there are numerous other avenues of exploration and study that focus on the interaction and control of non-biological systems. For a cybernetics program on a larger scale, such as in a small town or city, various hardware components and technologies may be useful. Here are some examples. 1. Sensor networks. Deploying a network of sensors throughout the town or city can provide real-time data that is essential for monitoring and feedback in a cybernetic system. These sensors can include environmental sensors, surveillance cameras, motion detectors, or even wearable devices to gather information about individuals' behaviors and interactions. 2. communication infrastructure.